Welcome back. We're getting ready to discuss example 3, but first we have to just talk about a little bit of vocabulary and a few other formulas. So the first is the diameter. So we're going to be talking about circles, okay? So every circle has a diameter, and the diameter, that is a segment that passes through the center of the circle and whose endpoints are on the circle. Okay, so let's look here. We have a circle, and this right here is the diameter. It passes through the center of the circle, and its endpoints are on, and it's a line segment. So it's not a line, it doesn't keep going on forever. Its endpoints are here, and it passes through the center of the circle. So that's called the diameter. All right. The radius is a segment whose endpoints are the center of the circle. Why am I having such a hard time reading? Okay, a radius is a segment, so a line segment whose endpoints are the center of the circle and a point on the circle. So here's the center, and here's a point, and so this is a radius. But there's a lot of radiuses. I mean, radii would be plural. And really, there's a lot of diameters as well. So if I was to draw a different picture right over here, and here's my center, and I was going to make a diameter, just really anything. I mean, that's a diameter, that's a diameter. There's like probably like infinite amount of diameters that you could draw through the center. Okay, that's diameter. This is not a diameter. I know I'm jumping back to diameter. Something like this, where it doesn't go through, it goes like that. That's actually called something else that you're going to learn about later in the year. That's called a chord. So the key is that it has to go through that center. So that's not a diameter. But we were talking about radius. And so there's really infinite amount of radii that can be drawn as well, because it starts at the center and then just goes out right there. There's just a whole bunch. These are all radii, which is the plural for radius, and there's just a lot. But the cool thing about radii is every radius drawn here is they're all the same length, because the center is in the middle, right? And when you go from the middle to the edge of the circle, they're all the same, and all the diameters are the same length as well in a particular circle. So, the radius, I didn't highlight it. The radius is the segment whose endpoint are the center of the circle and a point on the circle. All right, cool. Then there is circumference, okay? Circumference is really the same thing as, hold on, I have to sneeze. Excuse me. It is the same thing as the perimeter, but they just use it, like they give it a fancy word for circles. It's just the distance around the circle. So if we go here, we go the distance around, that's just the same thing as the perimeter of a circle, but they call it the circumference. They give it a nice little fancy, its own fancy name. And basically what happens is if you were to cut that circle, it would just come out in a straight line like that, right? So if you had I wish I had a string. I don't really have a string. Oh, I have a cord. I got lots of cords. Hold on. Let me use this. I'll use my phone charging cord. I'm kind of trying to be like MacGyver right now. So if we have a string, right? And then we can make this string into a circle. Just bear with me on that being a really good circle. But if we cut that circle right there, it ends up being, oh, let's make it a smaller. So if it's a string, okay, so we need a smaller little circle. Okay, here's a smaller. So the distance around is the perimeter. I mean, it's called the circumference, which is the same idea as the perimeter. And then if you were to cut it right there, it is really just a straight line, right? So you just figure out how long that is, and that is what the circumference is of a circle. All right, so I'm going to put this back on my phone so my phone doesn't die while I'm trying to record this video for you all. Okay, so yeah, so the circumference is really just a straight line if you were to cut it, but you bend it around and then there you get, woohoo, a circle. So let's look at the formulas for the circumference. There's two, and they're the same, they're just using different variables. So first, the circumference is equal to pi times the diameter, all right? So you take pi, 3.14, you multiply it by that diameter, you get the circumference, or the circumference is 2 pi r, okay? And that's 2 times pi times radius. Now let's think about that for a second. If we have this right here, 2 radiuses. If we have a circle, and here's the center, right? And from here, this is a radius. And then if we went from here, this is also a radius. And if we add those, radius plus radius is going to give us 2 radiuses. Okay, and really this is the same thing as a diameter, that whole thing, that's a diameter. So basically you're doing the same thing. You have this pi, and then diameter is the same thing as 2 radiuses. So it's just the same formula, it's just broken down as, okay, pi times the whole diameter, or 2 pi r, where 2r are the same thing as a diameter. Okay, so that's the circumference formula, and then the area formula is going to be pi r squared. And these are things that you should have memorized, okay? This is just, you know, basic formula for geometry stuff. So this, I'm going to say, is, where's my lovely pink pencil? These need to be flashcards. Flashcards. Okay, flashcards right there, both of these. Okay, cool. So let's go ahead and do an example. So this says find the circumference and area of a circle with radius 8 centimeters. So we are finding the circumference. I always like to highlight the keywords. Area of a circle, right? We need to know its shape. And it has the radius is 8 centimeters. So I'm going to go ahead and just draw that first. So I have a circle. Here we go. They're giving me the radius, and it's 8 centimeters. Perfect. So the first thing I'm going to do is write down, oh, well, you couldn't even see it. I'm sorry. Okay, hopefully you can see that now. Okay, so yeah, just drew that. Circumference, we're going to find the circumference. So we have 2 different formulas. I'm going to use the formula that has a radius, right? So I'm going to use this one. So C equals 2 pi r, and the radius is equal to 8 centimeters. So I'm going to go ahead and substitute that in. And we have 8 centimeters, okay? And then we just multiply the numbers, 2 times 8, which is 16, and pi, and then centimeters. And we'll just leave it in units of pi. How do they call that? They call it, hold on a second. Let me go get a geometry book. Hold on. They call it, it's like units of pi. It's just when you just leave the pi in the answer. Hold on. Let me get to this section really quick so I give you the correct, it looks like in your homework they want you to, oh yeah, leave in terms of pi. So there's going to be some where you're going to leave in terms of pi. And then there's going to be some where they want you to just figure out and round to the nearest hundredth. So we practice that a lot in the warm-up rounding. So we would just go 16 times 3.14. I mean, we can do that really quick. Let's just do it. Okay, so 16, or 3.14 has more digits, so we'll put this 3.14 and we'll times it by 16. Okie doke. 4 times 6 is 24. Write the 4, carry the 2. 6 times 1, 6 plus 2, 8. Why did I put the times there? Oh my goodness. Okay, all right. Okay, 24, that's 2. 6 times 3 is 18. All right, then we go to the 10 spot, so we make a 0. 1 times 4 is 4. 1 times 1 is 1. 1 times 3 is 3. And then we add, right? 4 plus 0 is 4. 8 plus 4 is 12. Write the 2, carry the 1. 1 plus 8 is 9, plus 1 is 10. Write the 0, carry the 1. 3 plus 1 is 4, plus 1 is 5. Oh, gosh. And then we have 2 decimal places, so right there. So this is, circumference is 50.24 centimeters. All right. Or if we were to leave in terms of pi, which they'll ask you to do in your homework as well, leave in terms of pi, then the answer is just 16 pi centimeters. And I just love when we leave them in terms of pi because it's just, boom, 16 pi. That's just it. All right, so that's circumference. Let's go ahead and do the area. So the area is right here. Area equals pi r squared, and our r is 8 centimeters. Okay, so we substitute that in. Area equals pi and 8 centimeters squared. Remember, 8 centimeters squared is the same thing as 8 centimeters times 8 centimeters. So we can just go 8 times 8 is 64, and centimeters times centimeters is centimeters squared. And then we'd have our answer 80 in terms of pi, right? Which would be 64. You always write the number, and then you write the pi, and then you write the units. So that's how you'd write it in terms of pi. But we're going to go ahead and determine what. Oh, this is approximate. I should have put approximate. Whenever you multiply that, this is approximate. It's not exact. It's approximate because we're using pi as 3.14, and 3.14 is not what pi is. 3.14 is an approximation for pi, right? It's really, really close, but it's not exact. Here, 16 pi is exact. So we can write an equal sign. But anytime you put pi into your calculator and then you round, you're really just, it's giving you approximate value. So it's always good to understand the difference between exact and approximate. Okay, so this is approximate, this is exact. Okay, so we have the exact value here, right? 64 pi centimeters squared. That is the exact value. We did not round pi. Pi is there in its entirety. But we are going to determine what the approximate value is. And so we're going to go 3.14 times 64. Now we put 3.14 on top because 3.14 has 1, 2, 3 digits. 64 is a bigger number, but only has 2 digits. So we put the number with the most digits on top. 4 times 4 is 16, carry the 1. 4 times 1 is 4, plus 1 is 5. 4 times 3 is 12. And then we go to the 10, so we put a 0 here. 6 times 4 is 24. Write the 4, carry the 2. 6 times 1 is 6, plus 2 is 8. 6 times 3 is 18. And then we add 6 plus 0 is 6. 5 plus 4 is 9. 2 plus 8 is 10. Oh, wait, boom, boom, boom. Okay, so 8 plus 1 is 9, plus 1 is 10. And then we have 2. And then how many places for the decimal? So there's 1, 2, so that means we come over here 1, 2. And we get 200.96, and that's the 100 place, so we're good. So approximately 296 centimeters squared. And let me just think about this really quick. So if I was to estimate this, this is about like 60, right? And this is about 3. And so 60 times 3 is basically the same thing as 3 times 6, which is 18. With a 0 is 180. Now 64 is bigger than 60, which means our number is going to be bigger than 180, and 3.14 is bigger than 3, so that means that we're going to have something bigger than 180, a little bit bigger. And so this answer really seems reasonable to me. Okay, so it's always just good to just kind of look back and say, hey, is this answer seem like it's about right? So there you go. This is exact form. This is the approximate. So you'll have to do it both ways on your homework. Okay, great. Let's go ahead and do this one more time. So we're going to find the circumference and area of a circle with a radius of 14 centimeters. So find the circumference and the area of a circle with a radius of 14 centimeters. So I'm going to draw a picture. I always like to draw pictures. Okay, I'm dealing with a circle. It's a radius, and it's 14 centimeters. 14 centimeters. Okay, so circumference first. Since I'm dealing with a radius, I'm going to use the formula dealing with a radius, which is 2 pi r. So we have the circumference equals 2 pi r, where the radius is equal to 14 centimeters. We go ahead and substitute that in. We get 2 pi times 14 centimeters. All right, so we just multiply the numbers. 14 times 2 is 28. So we get 28 pi. So it always goes numbers, pi, then units, centimeters. So that's leaving our terms in pi, okay, which is always my favorite. And then, oh man, what happened there? Okay. All right, then we're going to get the approximate value. So C is approximate. So we're going to go 28 times 3.14, but 3.14 needs to be on top because it has more digits. 28 is here. Then we just multiply 8 times 4 is 32. Carry the 3. 8 times 1 is 8. Plus 3 is 11. Write the 1. Carry the 1. 8 times 3 is 24. Plus 1 is 25. Now we're to the tens place. We add a 0. 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. Then we add 2. 2 plus 0 is 2. 1 plus 8 is 9. 5 plus 2 is 7. 2 plus 8 is... No, I'm sorry. 2 plus 6 is 8. Ah! Okay. And then how many decimal places? 1, 2. So we move this over 2. And we get approximately 87.92 centimeters. All right, so this is our answer in terms of pi, which is the exact, and this is our approximate answer here. So there we have it. That is the circumference, the distance around the circle, okay? So now let's go ahead and figure out what the area is. The area, our formula for the area, remember I want you to write it down every time, is pi r squared, and r is equal to 14 centimeters. Okay, we're going to substitute that in. So we get area equals pi 14 centimeters squared, right, which is the same thing as 14 centimeters times 14 centimeters, right? Okay, cool. So I don't necessarily know what 14 times 14 is off the top of my head. So we're going to go ahead and figure that out really quick. 14 times 14. And like I said, it's always good to do these calculations and use your brain, okay? The more you use your brain, the better your brain gets. So use it. It's like exercise. 4 times 4 is 16. Write the 6, carry the 1. 4 times 1 is 4, plus 1 is 5. We're going to the tens place, so add a 0. 1 times 4 is 4. 1 times 1 is 1. And then we add, right? 6, and then 5 plus 4 is 9. Area equals pi times 196, and then centimeters times centimeters is centimeters squared, right? And now I'm just going to rewrite it. It's multiplication, so I can switch around the order, and that's totally okay. Why is that okay, though? It's okay because of the, this would be the commutative property of multiplication, which basically says A times B is the same thing as B times A. All right, that's the commutative property of multiplication. Whew! All right, so number, we put pi, we put the units. That is the exact, okay, but we want to know the approximate value, so we're going to go ahead and take 196 and multiply it by 3.14. This one, it doesn't matter which one you put on the bottom and which one you put on the top because they both have 3 digits. I'm going to put the 3.14 just because these numbers are just easier to multiply. I mean, it's not a big deal, but whatever. 4 times 6 is 24, right? The 4 carry the 2. 4 times 9 is 36. Plus 2 is 38. Right, the 8 carry the 3. 4 times 1 is 4, plus 3 is 7. And then we're going to add another 0 because it's in the tens place. 1 times 6 is 6. 1 times 9 is 9. 1 times 1 is 1. Now we're in the hundreds place, so we add 2 zeros. And then 3 times 6 is 18, right? The 8 carry the 1. 3 times 9 is 27, plus 1 is 28, right? The 8 carry the 2. And 3 times 1 is 3, plus 2 is 5. And then we add up all these wonderful numbers. 4 plus 0 is 4. 8 plus 6 is 14, right? The 4 carry the 1. On this one, I'm going to go 9 plus 1 because that's 10. And then 7 plus 8 is 15, and 15 plus 10 is 25. So right, the 5 carry the 2. Here, I always like to group like sets of 10 together, right? So 8 plus 2 is 10, and then plus the 1 is 11. Whenever I'm adding like a bunch of numbers like that. And then count up the decimals, right? 1, 2, and then there we have it. Area is approximate to 615.44 centimeters squared. All right, let's think about that. 196 is really, really close to 200. And 3.14 is really, really close to 3. And so if we go 200 times 3, we get 600, you know. And 196 is a little less, but 3.14 is a little bit more. And so it gets a little bit more. All right, cool. So that's really, really close. I'd say that that looks pretty good. So there's our answers right there. The answer in terms of pi, and then the approximate rounded to the nearest hundredth. All right, well, go ahead, get started on your homework, and we will see you next time within our next video.